Good afternoon, everybody. My name is Gia. I'm one of the general surgery residents at Western University. Very honored to be here today. There's been some incredible talks thus far, and I'm very excited to share with you guys our mixed reality platform for teaching surgical skills. Myself and my partners have no disclosures at all. So, as many of you in the audience can attest to, as surgeons and educators, procedural skills, surgical techniques can be very challenging, both to teach and also to learn. Currently, our gold standard for these fundamental skills like suturing or surgical knot tying still remains the apprenticeship model, which was coined by William Halstead back in 1904, which is you see one, you do one, and then sometimes you teach one. Unfortunately, there are some limitations to this, namely more and more so limitations of the educator. I'm not sure about you guys, but I think every week or every month I get emails about teaching surgical skills to medical students and first-year residents. And I think as practices become more and more busy, we are more limited. And this came to a head in COVID during the pandemic, where in-person workshops were canceled. Medical students weren't allowed in the operating rooms, and really, this is what brought about the idea for this project. Fortunately for us, in the last decade or two, there's been advances in display technologies, which have brought about these emerging technologies, such as extended reality technologies. Really, they allow us to create these nice holographic or simulated environments and afford us different options for visualization, for anatomy or also procedural skills. For those of you who are not familiar, extended realities incorporates a whole spectrum of technologies. This, in the bottom left of the screen, is a modified reality-virtuality continuum first described by Milgram back in 1994. On one, I don't have a pointer. Oh, I do. On one end, towards the right, or towards the left, there would be our true reality, and then more towards the right would be a virtual reality. I think most of us have experience with some sort of virtual reality, VR games or simulations, things like that. Things that we're less familiar with are the augmented realities, and what this is essentially is you can see your physical environment and there's overlays of virtual components on top of it. And then finally, what we're going to focus on today is mixed reality, which is a term coined by Microsoft when they came out with the HoloLens, which I have up here. Essentially, the difference is this is augmented reality, but you can overlay and interact with these virtual elements directly. These technologies really have allowed us to move away from traditional teaching methods, and we've been able to develop some very interesting new technologies to help teach and innovate and educate. I think someone following me is also going to be talking about the HoloLens intraoperatively, which will be very exciting to see. Despite its use in a lot of other things in different industries, for surgical education specifically, it's been pretty limited. Thus far, really, it's been showing complex anatomy or showing videos in 2D but in a 3D space. That is until our group came and did some work here, which I'm excited to share with you guys today. The reason for, I think, some of the difficulty with innovating with this so far in surgical education is that it's pretty expensive, it's difficult, and it's pretty labor intensive as well. And we encountered all of these issues as well when we were looking at our product. So the goal of our project was to create a high-fidelity 3D holographic animation to teach surgical skills using mixed reality technology, but in a way that it was cost-effective and reproducible easily. I'll show you in a second, but we were able to cut down the cost from thousands and thousands of dollars to hundreds of dollars, and from dozens of hours to a couple hours per animation. And the idea is we wanted to create a surgical mentor, essentially, a holographic mentor. So when we were brainstorming for this project, initially we wanted to hit 3 key objectives to make things easy and basically automatable in the future. So one, we wanted to be able to take our own hands and record them and be able to use that data afterwards to turn them into animations. 2, we wanted to take other objects such as sutures or needles or needle drivers and other instruments and do the same thing with that. And 3, like we talked about, we really want to focus on the accessibility. So we want it to be cheap and we want it to be easy to reproduce in the future. We went through many, many different ways of doing it. We looked at Hollywood options of full body motion capture suits, which were very expensive. We looked at gloves that could capture motion as well, which was also very expensive. We looked at fully manually animating hand motions and sutures and strings like that, and that was also very expensive and time consuming. Ultimately, we settled on a very good option, I think, which is what we're presenting to you today. So essentially, we used the Oculus Quest 2, which is like $200 US, and we just happen to have one. And it's a virtual reality device, but it has pass-through options and innate hand tracking options as well. And there's a free application, the APS Mocap Fusion app, which we're able to essentially use to capture all of our hand motion. And we dropped all of this into Blender once we recorded all of our hand motions, and we're able to develop our string with physics and gravity and things like that. And finally, we were able to export it into Unity, which is just a game engine software for the development of our actual mixed reality application. After all that talk, I will finally show you just a video demo I recorded last week at home with me wearing the HoloLens headset with our application. So unfortunately, our application has like 7 videos and multiple different modules. I can't show you all of it. The idea is I just wanted to show you like a minute of the functionality, our user interface of our application. This is just going through and teaching medical students how to suture and hand tie, essentially. This is our hand menu where you can cycle through different modules that you want to look at, and this is the actual hand model for teaching single-hand surgical hand ties. You can see, obviously, everything is malleable. The device you can control either with the gestures or with voice, and here I am just locking it in place so I can pretend to learn the motions myself. This is a scrubber where we can go back and forth in the animation, and here you can select the speed for different levels of trainees and learners. You have to watch me awkwardly learn how to hand tie now. Yeah, so I think everybody can appreciate the benefit of mixed reality for something like this. Virtual reality, you wouldn't be able to see your hands. So the benefit of having the physical world in front of us with virtual elements is for things like this, in my opinion. I have my device here as well as my application. If anybody is interested afterwards, happy to show it to you. Just come find me. I'm sitting somewhere to the left of myself. All right, I think that's a pretty good demo. So, of course, after we created the application, we wanted to make sure that it actually works. And the question is, can people actually learn from our holograms in order to learn surgical hand ties or other procedural skills, which we'll expand to later. We've since done a much bigger study, but I'm presenting at a different conference. So for now, I'll just be showing you the feasibility study. Essentially, we took 20 participants with no previous medical or hand tie knowledge at all, and we randomized them either to a control group, which is just a person, aka me, showing them the exact motions, compared to our hologram group. And we took the McGill, it's called the Mistel scale, and it's for laparoscopic knot tying and grading, and we just adapted that for our purposes. There was lots of data, but essentially the takeaway is that both using holograms and in-person learning, people were able to learn how to hand tie with no previous knowledge. Interestingly, it's 80% for the in-person group and 70% for the hologram group, but interestingly, subjectively, and I think there's a little bit of bias, but subjectively, the participants much preferred using the holograms. There is a little bit of bias with like new technology that's cool, but I thought that was very interesting. And just subjectively talking to the participants, they were they thought it was very interesting. They wanted to learn, and they really liked it. So I think I'm over time, but in conclusion, we developed a low-cost and automated methodology for creating high-fidelity 3D holographic animations. We developed an early application for teaching surgical knot tying, and our early pilot study demonstrates that it works. Thank you. Happy to take questions.